And so we are once again recording a fourth video. Today we are going to move away from fourth and move into slightly more recent concatenative language, at least for the loops and conditions, because I do not particularly like how fourth handles loops and conditions because it kind of stops being a concatenative programming language and starts being like a more of an imperative stuff. Um, and so I think I'm going to go with factor in on this one because factor basically allows you to define like a quotation. They call it a quotation, basically like a lambda. And this quotation is going to be executed on each loop iteration. We can do something similar. It doesn't have to be exactly the same, but um, yeah, it can be similar. So they can define here arrays. This is a quotation. I don't like this syntax, by the way. I'm going to swap them because it makes more sense for this to be the array and this be the quotation. At least like the symbol that identifies each thing. Um, yeah, and basically here, each one of the elements is going to be passed into the quotation via the stack, and then the quotation is executed basically. So yeah, I think that we are going to do that because like the other way we can do it is by the fourth loops, and I don't like them because let me see if I can get anything. Yeah, so basically here you have the stuff, then you have if, then you have this stuff, and then this is the termination. So this is how ifs terminating fourth is like with a then, which is interesting. Here we have if, then this else, yeah, if, then this is the then, this is the else, and the then is actually ends. Okay, so yeah, and this is how you chain them. Yeah, so I don't like it. Basically, I don't like it, so I'm not going to implement it. I'm currently training by not training, but I'm currently downloading ImageNet for a personal project. I know that I keep complaining about clankers, and I do not like them, but ironically, I develop clankers on my free time, um, as part of my master's degree, and I'm reasonably successful on that regard. But I do not make it for money. It's literally like it's not even love for the game because I don't like clankers. It's just I don't know why. Anyways, I hope like this ImageNet stuff does not fuck up the recording because it is a data set with 150 something gigabytes. So yeah. Anyways, this one could be cleaned up. Let's try to like do some basic house cleaning to begin with. So this function does not need to be here because this only stores code, right? This is never going to be called. So we can move it there, and we can call it like underscore just to make sure that yeah, this is not supposed to be called. It just holds the code for of of all primitives. Yeah, something like this. Then what else? What else? Well, this could well, but it does make sense for this to be more or less in the same like segment, right? So maybe we can actually put it upwards again. And I want to create a table. Yeah, I also want to clean all of this shit. So we can create a table to simplify things. So this can be, yeah, this can go upwards. Yeah. Then this stuff can go into a table. This still needs to be like variables because they basically are created by the assembler. Like these are basically labels that the assembler outputs. But this stuff we are computing them, right? So let's create a table. We can say um, something like primitives, I guess, right? And this is going to be hard coded because we are not going to add primitives while we are executing, right? Because if we want to add stuff, we just add words. It does not make sense to add primitives. So a primitive is going to need is going to basically be a word, right? It's still a word. So we can say const char words. Then it needs a begin and an end, right? So we can also say const char begin, and this is basically the pointer from here, and it also needs an end, and it needs a size, right? And this can actually be size t. Yeah. So we can do the following. We can create yeah, we cannot. Yeah, we can create. I was thinking if we could use like strings as index, but this is C, so it does not make much sense. So we currently have dup. So this is dup, and we need this stuff, right? Why don't you like it with a non-aggregate type const? Don't you like the? What are you talking about? I'll see it later. Then we need a begin, and this one will need to be initialized at runtime, and everything else will will need to be initialized at runtime. Yeah. So, I mean, I guess we can initialize. Yeah, why not? We can initialize all of this in the same function. So we can just say 1, 2, 3, 4, 5, 6. Yeah, we can put here 6, and we can say static assert, and you can just make sure that like the hard thing is that since this is being exported by the assembler, we don't even know how many of them are at compile time, right? If this was an enum, we could have a trick to actually do that, but yeah, I don't know. We can just fucking what the fuck is this Windows? Okay, we can try. I mean, what? There is really not anything we can do about this. Yeah, there isn't really anything we can static assert here. Well, we just need to remember that this actually is the way it is. Yeah, there isn't really much. Okay. Anyways, we can create a void function. We can call it init. And here we are going to do the following. We are basically going to assign all of the stuff. Oh, but this dup. Nah, this is going to work because yeah, this is going to be, or is it going to work? I think it's going to work because it's going to be copied into static memory, right? So let's make it static. I think it's going to work. So then, yeah, we basically just need to do this shit a bunch of times. Dup underscore begin. I cannot type. Okay. And these can be casted like so, and then ends. I don't know why, but this has a very strange font. Did I change the font? I don't think I did. I don't like this font. There's something very wrong. Yeah. I don't know. Alright. And then size. And size can be this scheisse we did here. Yeah, basically that. But since we already have... Well, it doesn't cost to cast it again, does it? You can just say this. Something like this, right? And then we can just do the same for everything else. So this is loop. Then we get drop swap with call and return is actually not used. Or is it? Because this call is also not a primitive. Okay, so we in terms of primitives, we only have 1, 2, 3, 1, 2, 3, 4 actually. Okay. So we don't need that. So we get this. This is 1. This is 2. This is 3. And here we can just swap this for drop. This one for swap. This one for lit, right? And lit is not even going to be used, or is it? Do I use that lit stuff there? Oh, I do. Okay. Yeah, it makes total sense then. And then for the call, where do I use call? Am I still using call? I don't think I'm using call, because for now, yeah, to do calls, I'm just using this macro. So I can actually remove this shit. Call begin, call end, exactly. And then from here, I'm still just using return, right? Yeah, return is in fact being used. So does it? Maybe I want to include, well, but the return is, yeah, I'm gonna leave it like this. I'm gonna leave it like this. Yeah. All right. So here we can just initialize all of that shit, and then we can replace this stuff by a simple init, right? And this, I don't know, I would like to move this into a separate location, but at the same time, like, I could do, yeah. Yeah, I'm gonna leave it like this for now. And here we can document this a little bit better. So this is the pointer to the second. This is the value of t, right? And this is a, and that is a temporary variable, right? It's a temp register. So this is more or less what we have. This is top of stack, pointer to second element of stack, and this is temp. All right. Then we have some issues. Yeah, so now we can clean up all of this shit. We can clean up all of these because we can simply say, we still need to have this like here. There's nothing we can do about it, right? But here, yeah. So lead size, yeah, I have leads. Oh, so one thing I can do, I guess so. I can do the following. Type def enum, and I can do primitive. I can call it p underscore dupe or something. And this is 0. And then I can have I can have drop and everything, right? So it's easier to access and know what's going on. And this is swap, and this is lit, right? And then I can have p underscore counts, and here I can actually do that. And now this is okay, it's better. And this can be primitive, right? I don't like just the p. I should, yeah. I can say primitive. Okay. And here now I can just say primitive dupe and everything like so. I know it's a bit longer, but This way we are not using like hard coded stuff, and it's easier to work with. All right, let me just align off this because of OCP. And so here we can do the following. We can extract i64. We can extract well, but in that case I will need to, yeah, I guess so. Fuck, okay. So in this case I need to extract this into a type, right? It can be like f. It can be, in this case it needs to be primitive, right? And the other one can be primitive kind or something like this, I guess. And this can be init primitives. Okay, so we can init primitives, and then here we can extract the primitive p by just saying primitives primitive lit, and now we have access to everything, right? We have access to everything. But here we could even like abstract this even further, but I'm gonna wait a little bit because I want to handle everything else to actually know what the abstraction is going to look like. So we are just going to duplicate that and assume that's it. All right, but this was the special case because it's a literal, it needs to be the instruction needs to be patched and everything, but everything else can actually be handled separately. Instead of doing all of this, we can say, we can just have a loop. So we can have an else here or something like so, and inside this else, we don't even need to have an else, right? We can just have here a continue. It's like so. And then here you can just loop through for say st 0 I is less than. Well, here this is going to be actually fuck. Okay, because these are accessible, but this is not, right? This is not accessible. So there is a distinction between callable or non-callable primitives, or accessible at least. How do I call that? Primitive I don't know, like callable counts? I don't know. This is callable as is, this one is not callable as is, so this one callable without primitives, without patching, and this one requires patching. Or I could do the following. So this is a pointer. This also takes 64 bits. So the structure packing is like, there is nothing I can do about structure packing. I can just put a flag here. Needs patching. Why not? So if I do that, I don't need to do this. And here, by default, this is going to be zero initialized, right? So here I just need to say, okay, that's fine, but the needs patching here is true. So, well, since I have it like that, I can just, okay, I can format that later. So this needs patching can be true. And so here, I can just say loop through everything, right? So primitives count I++, and you must do that stuff like so. But here you are going to compare the word to primitives I dot words, like so. And if that's true, you do something, else you just don't do anything. And I can just copy this, right? I can just copy this. But this is not the only thing we need. We also need to make sure that primitives I does not need patching, right? Right, something like this. If it needs patching, we can just ignore it. All right, so here we just need to provide, well, let me extract the primitive into a variable p, it's easier. So yeah, something like this, and I can have p, and then p. And here we just say p, doesn't even need to be a pointer because this is already a pointer because it was initialized like that. P.begin and p.size, right? Something like this. And here we just need to call p.begin. That's it. That's everything we need, okay? And if we found it, we can break, right? And we break from this loop and it continues to the next one. But in that case, yeah, maybe we need some way of identifying, because once, like, if we found stuff here, well, we could even extract that. It's one way of, well, I don't know, to be honest. Let's keep this like that. So let's say found primitive is false. In reality, this actually needs to be initialized every single time, right? Well, I could in fact initialize it inside the loop. Yeah, why not? And here, if it found it, it first sets it like that, and then it breaks from this inner loop. It comes here, and we only do this shit else, in the else case, right? Oh, I do need call. Fuck, I removed call, but I needed call. Fuck. Do I still have that? Fuck, I completely forgot, man. Anyways, let's see. I can fix that in a bit. So all of this code, so we can say something like this. If found primitive, we can continue, right? Else, this is the last thing we can try to do, right? There is nothing else we can do. All right, so we can remove all of these codes. Okay, why don't you like print stack? What is going on? Too many arguments. What the fuck is going out of a sudden? This is completely okay. Yeah, let's, so red size, well, we can do something about it, because like return is not really a primitive, or is it? How do I handle return actually? Well, but return is a special one, isn't it? Yeah, let's keep it separate, and here we can just add size t return size, like so, and we can just initialize that here. Yeah, I think it's the best approach. This is end, this is return begin. Yeah, so that should be handled, but now call is fucked. Do I still have the function or whatever I was doing? Yeah, I still have it. It was this one, I remember. Yeah, I think it was this one. So I removed stuff that I should not have removed, but it's fine. So here, yeah, I remember this shit. This can be a 0. This one, I don't even remember what I used here the last time. I think I used the temporary register, right? So I can just do R14, R14, R14. So we can use the temporary register. Here we still need the labels and everything. So this is going to be call. Here we need that to demark the stuff. So call begin, and we need that. Call ends, and we need to bring, oh, I still have that here. Okay. And I can just add that here. So call size. Because this is different. So this is not really a primitive. This is like stuff that primitives are built on top of. But we may change. Okay, this is actually wrong. This is right. We actually may change our idea later. So let me just patch that. Fuck. This is call. So call size equal call begin minus the other way around actually. It's call ends minus call begin, and same stuff here. Right. Okay. So that should be handled. And so we abstracted at least these primitives away. This one, there's nothing we can do about it. It needs to be separate. This one could be more or less like generalized, but I don't want to do that, so I'm not going to. Then, yeah, that one, it's okay. And then we found in the, like the last step, we just try to find it in the vocabulary. Okay. So we, well, yeah. I'm thinking if it actually makes sense to have call within the primitive's static structure, right? Or array in this case. Just to have this stuff more or less like generalized, but let me think about this actually. I could have some constant here, at least. Yeah, I can have something like call underscore patch offset, and I can just say 2. And this is just for x86 64. Like the entire program only works for x86 64. It does not work for any other architecture right now. And here I can just say that. Okay. So it's not that bad, right? It's not that bad. All right, and I think that's basically it. We cleaned it up a little bit, or I don't know if it actually increased in size, but now let's try it just to make sure. So if I do this, okay. If I do a swap, okay. If I do the dup 42 swap, I don't know. No, swap is not going to do anything. So 69. Okay, do that, bam, and then I define a word that calls d, and then actually d 420, and then another d, and I call that word. We are going to have so it did a dup, yeah, dup, then 42, 69, then yeah, that one, then this was defined, and that was done. So dup 42, 69, 420 is the middle, then dup 42, 69 for then. So it's correct. Okay. And the code segment is not that big, let's be honest. The code segment is not that big. So it works fine. I need to improve these comments, but it's okay. Then here, I was thinking about this. I don't like the name codes because this is a bump allocator. Let's not like deceive ourselves. This is a bump allocator, nothing else, right? So we can treat it like a bump allocator. So we can simplify that. Let's allocate 1 gig, well, 16 megabytes is enough. We can say, since it's a bump allocator, but for executable memory, we can call it bump E, bumpy. Why not? So bumpy capacity, I think it's good. Bumpy. So this is our executable bump allocator, and we can just define it like this, bumpy. Okay. So this is the executable bump allocator, right? And this is our data stack. Okay. We don't need anything like that for now. We don't even need to keep track of the start. We can just keep moving this stuff. So we don't need that, or do code append. We actually need that, but we can call it results. Yeah, we can call that results. Result, and bumpy is actually the one that's going to be moved. This one reuses the stuff, so it's fine. Okay, so it was not that hard to do this change. Yeah, here we just need to say char bumpy starts, right? And this is bumpy capacity, and we should check that. And here we just say bumpy is equal to bumpy start. So this is more like a init bumpy. So here we have init primitives. Here we have init bumpy, but I don't feel like extracting this into a function because it doesn't actually need to. Yeah, it doesn't need to be extracted, to be honest. Here we can even do something even brilliant. We can just say unmap. Isn't it unmap? Oh, nmap or something? What was the function? Unmap? No. So let me check mmap. Oh, m unmap. Okay, it was the other one. M unmap, something like this. Okay, and this is going to get address and the length. So this is just going to be bumpy start, and the length is going to be bumpy capacity. Oh, and this one is not even capacity. This is actual size, right? Because this is not a dynamic array. This is a static array. This is size, right? Do we want to check? I mean, we could check it, but it makes no difference because we are already exiting the program, so fuck it. Here, bumpy count will be basically, what will this be? Well, it will just be bumpy minus bumpy start. Yeah, that's it. And here we just need to access it bumpy, like so. And that's, well, not really bumpy start actually. Yeah, we just need to access bumpy start. Here, the address will just be, so this one, yeah, it's just going to be bumpy. Cool, that's it. And here, it's just going to be bumpy. So it's even simpler. You see, guys, this is much simpler. Yeah, so bumpy is our new code segment. And now we are ready to actually implement lambdas or closures or quotes, whatever you want to call them, right? So what's going to be the syntax? So once, like, let's create a file. Let's say, I don't know, example dot or something. We currently can define words by doing this. So you can do loop swap drop. I don't know. Something like this, right? But and this basically adds this name into the vocabulary, and we can just call this by name. But to define a lambda, I was thinking about this. So we can use these curly braces, and then we can do the same stuff, right? We can just do this like so. But while this definition does not change the stack, okay, it just changes the vocabulary. This one is not going to change the vocabulary, but is going to push onto the stack the pointer to this function. This is how I'm thinking about it. Like, does it make sense, guys? Like, I think it does make sense, because if I define this in line, and I let's say, if I define the low of my loop, for example, I define the max of my loop, I define this, and then I say for, what this is going to do is that I'm going to have 0, 10 on the stack, then I'm going to have the pointer to the quote. I can say, yeah, I can say quote, something like this. And then for loop, the for loop is going to pop these two. It's going to remove these two. Is going to push the first element onto the stack, and is going to call this like so. Of course, like, let's not forget, yeah, this is still as a continuation, so it can be stuff there. It doesn't have to, but it can be stuff there. For is going to pop these two, right? It is also going, well, it's going to consume everything. Actually, it's going to consume all of this. It's going to push the iterator, the current iterator. Is going to call the quote, so it's going to call the quote, and it's going to keep calling the quotes and incrementing the iterator by 1 each time until it reaches the end condition, like this one. So I think that's, I mean, it makes sense to me. I think that's the best approach, to be honest. So to support this, what do we actually need? So I think we will need more special stuff. So the first curly brace is going to map into this stuff, and this is going to map into this stuff. So they are going to be similar, more or less similar, but slightly different, because while in here we set compilation modes, that's fine. We did here, we store it inside the compiled words. Here we don't care about that, right? So what we actually care about, so let's add an else if here, and here we need to handle this case. We can say the same. Yeah, we can say the same. Right, but here that's the same. Here we don't care about the next word. It does not, yeah, it does not matter to us. We also don't care about this, we don't care about this, we don't care about this. We only care about pushing the current bumpy address onto the stack. So that's what we are going to do. Yeah, we can immediately execute it. Well, not really. We actually need to do this. Right, we actually need to do that. Where is it? Here. So we need to do that. And here, this one needs to be the literal. We can reuse the same code. We can reuse the same code like this. Here, this is just going to be bumpy, like this. And bumpy is already a pointer, right? So, well, just to be safe, I can say int64 address bumpy, because I'm not really sure how the C compiler is going to cast all of this shit, so we can say that. So this is basically the first the first instruction that's going to be compiled. Then we are going to compile everything else the same way. Like, we are going to, like, this is no change. We don't need to do anything else, because we're already inside compilation mode, so stuff will be appended, basically. And once we get into this place, or in this case, this place, we need to do also something very similar, but slightly different. Right, so once we close the closure, or close the quotes, we can append return, sure, and we can do that, but we don't need to do anything else. So like quotes are even simpler than word definitions. Yeah, and this should be everything. As strange as it can be, I think this is entire implementation for quotes. Like just these two branches, nothing else. Let's try them. So if I do, oh fuck, makes integer from pointer. Okay, I have to explicitly call custom. Where is it? Here. Okay. Are you happier now? It seems to be. So if I do this and I put dup inside and I do that and I close my sync, I basically have, let me also check. So if I do this, I dup that, the code should be more or less the same. Or should it? Huh. So I have that. Oh yeah, makes sense because here, that, wait, 24. Wait, but then, yeah, because here this one pushes stuff onto the stack actually, right? Yeah, it pushes a literal onto the stack, into the stack. But why the fuck is it pushing a literal? Wait a minute. What was the literal instruction? I already forgot. So move, fuck. I need to check what the fuck is the, oh wait. So lit, where is the code for lit? Yeah, this one, lit begin. Let me go there. Okay. Oh, lit begin doesn't add q. Okay. So that's why it is overlapping. So I think it's everything is correct actually. I think everything is correct because dup also does a add q at the beginning. Exactly. So this code is the same. So this is the add q. This is add quad word. Then here we have move q. So this is our move q, right? And then we somewhere in here we do that, and I know for a fact that the last 8 bytes, so 1 2 3 4 5 6 7 8, this should be, why is it 0 0 here? Oh, because this is little endian, right? So it's something like this. So some shit like this is actually the move absolute quad word or something like that. So it should be fine. It should actually be fine. So the last thing we actually need to do is to have some way of calling the quote, right? So let's try it. So I think like factor as something like apply or something. Where the fuck is the, okay, we can have something similar. Yeah, apply. So it takes the m value, what the fuck is it? Oh man, god, this is okay. I want something simpler. Yeah, go. We have an apply because my apply is just going to do the following. It's literally just, so we are going to have like some kind of address in here plus a continuation stack, right? The continuation of the stack. If I do apply, this is literally just going to pop the address and call it. That's it. This is my apply. So I think I'm just going to do that because like the apply from factory, it makes it super cumbersome right now. It may make like, it may actually be useful, but it's not useful for me at the moment. So this is okay. This is a parse apply. Yeah, I'm just going to do my own stuff. Okay, I'm just doing ignore factor. So let's add a new word. We can add a new word by saying the following. Where is it? Yeah, so we can add the word primitive apply, right? And then we actually need to implement it in assembly. So let's just do this, right? Wait, okay. fine. It's fine. Here we can call it apply, but we need to implement it. So this is before lit. So this is lit. Let's do that. It's after swap. So how are we going to implement this? So I think we just need to pop the stack, and the top of the stack is in R13, right? R13. So we just need to move R13 into some register. It can be R14, right? It can be. So we can just say move R13 into a temporary variable, which is R14. Then we need to, well, do we actually need to move our, I don't see. Oh no, because we are, yeah, we need to pop it. And when we pop a value, we need to move the S exactly. So we need to do that. So we are basically dropping it. So we just need to copy this. So this is basically a drop, right? A drop that saves the top into a temporary variable, right? So we save the top into a temp, then we move the second most value into the topmost value, and we subtract that from the stack. And then the last thing we need to do is just call the address stored in the temp variable, right? Like so. We just need to do that. And here we can ignore that here. Fuck, I fucked up this. Fucking hell. Okay, I did incorrect stuff. Fucking hell, what I did. Okay. 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 So this is apply. Let me try to see if I don't fuck up this now. So we're going to move R13 into R14, like so. Okay. Then we need to copy the drop stuff into here. So we move R13 into temp. We copy the second to the top. We subtract that from the stack. We don't need this. We just need that. Okay. And this is our apply. So this is apply implementation. Like as you can see, like quotes are super fast to compile because we just use the same code from the rest of the compiler, and then to apply them, it's also not that wasteful, to be honest. Just 4 assembly instructions, so it's fine. We can even like optimize this if we feel like it, but it's fine for now. So we just need then to do the following: this and that, right? Because that's the template boilerplate stuff we need always. And here we just need to swap this by the apply stuff. So this should be the entire implementation of apply, right? It should be everything. So now, if I create a quote that pushes the literal value 69 onto the stack, the quote is created, right? Oh, let me do the following so I can actually simply exemplify this even better. For now, let me have like a special thingy here. This is just for debug, by the way. I may think about having a special word for this in the future, but for now, I can have this and I can have the .s word, and I'm just going to say that. So print stack here. So yeah. So let me try again. So I'm going to create a quote that pushes 69 onto the stack. This is created. If I do fuck, so this doesn't work here. Why doesn't it work? .s does not work. What the fuck? Oh my god. Okay. But why? What's going on? Fuck. Okay. Let me. I can deal with it later. So let me go step by step. One more time. Try. Okay. 69 quotes is on the stack. This is the 69 quotes, right? So it is now on the stack. If I do apply is yeah, it's a single L. Okay, apply is not working. Apply is not working. Why is apply not working? So it pushes bumpy, yeah. Then it's not in compilation mode, right? Because yeah, it's not in compilation mode. So it enters this call. P begin, P is that. This is not that, this is correct. Begin, ends, and begin should be fine. Where did I make a fucky wuggy? Okay, so I move the top of the stack. So this is top, basically saying temp is equal to T, right? So this is it. Then I do yeah, so I basically do T is equal to SD referenced, right? Then I do S minus minus, and then I do temp. Why is it not working? What's going on actually? This should work, shouldn't it? Where exactly are you not working? So just to make sure, like print. Yeah. All right, so if I do this, then that's okay. If I do apply, yeah, it's exactly there that it fucks up. What the fuck is going on? Let me see if the clanker can easily debug that. So it's this one here. New shots. The apply word seg faults. Seg faults. Well, maybe the actual yeah. Let me just before doing that, let me try something. Let me try something. I can say so printf bumpy here, bam 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 bumpy. I can do that. Then yeah, I can do, but this is going to be hexadecimal, right? Let me print it as that in 64T. If I do that, just to double check. Okay, so this is bumpy. Oh, let me do this. Okay, so this is bumpy at the start. If I do this, look, I need to do that. And if I finish, there. Oh fuck, there is no bumpy. Fuck. Oh, I see. Fuck, I know what I did wrong. I know. Wait a minute. So this one is not a compile. This one actually needs to be. Oh. Does it make sense? Yeah, but yeah, if it's not in compile mode, it needs to be executed immediately. So it's a lit. We need to call lit immediately. Not this shit. Yeah, so we need to do lit address, like so. Lit address, and now this one is going to work, I think. Unused variable p. Why don't you? Yeah, because I'm not using it. Yeah, of course. So if I do that, and then I do this, and then this. Fucking hell! What did I do? Okay, it's okay. I closed. Okay, what am I doing? What the fuck? Okay, then that, and then I do that. 1399. Okay, that was the issue. How I completely fucked up. Okay, now it should work. Let's try it. So if I create a quote that pushes 69 onto the stack, and then I apply it, I should have 69 on top of the stack and not have the pointer. Exactly. So the quote was applied, boys. The quote was applied. And the funny thing about this is that now, if I create a quote that pushes 69 onto the stack, and I duplicate a bunch of times, so now I should have like, so the one pointer, duplicate 2, 3, 4. I should have 4 pointers. If I do apply like 3 times, fuck. Oh yeah, because apply pushes 69, so I need to apply swap. Okay, so wait. So if I do this now as a pointer to this quote on the stack. If I dupe it, right, I have 2 pointers. If I apply, I have 1 pointer followed by 69. So I need to swap, dupe, and apply again. Right, so this is how I can actually recurse on top of this. So if I keep doing this shit, it shouldn't stack fault. Yeah. So as long as I'm doing this, I'm pushing 69 onto the stack using this quote. So if I terminate now, yeah, exactly. Can you see it? So these were all of the 69, and basically this pointer was being carried around via these swaps, was being like carried around. And it like this is the last apply, and then I would swap these two, I would duplicate this, I would apply it, that duplication would be consumed by the apply, and then I would keep doing this kind of shit. Very interesting actually. So we have applies, right? We have applies. Now we basically need for loops, right? For loops. How am I going to implement for loops? I'm thinking if like to implement for loops, I do this. I expose the return stack into the user. Like I allow the user to play with the return stack, and like allowing the user to use the return stack is a forth way. So this is how forth works. Because they have these words called rets, or actually are something. Yeah, this shit. They have this stuff that allows you to move values onto the return stack. That's one option. Or I do something else, and I don't allow the user to even touch the return stack. I don't know how Factor does it. Do I have like return? Do I have like stuff? I don't know. Let's ask the Clanker. Does the four-factor programming language allow the user to manipulate the return stack forth? Because I genuinely do not know. I don't know that much about Factor. You can use the words like call and return. Yeah, but it does have a return stack. Our Factor return stack is not directly accessible or manipulatable like forth. That was what I was thinking about. Okay, so how do they implement each, for example? Okay, I need to search it like that. What? Each? Are you searching? Or? Okay. This is sequences, so it's implemented like the sequence operator each integer from. What is that? Okay, so this is the stuff. They do 2 over, they do that. Nib called 3 keep 1 plus, that's fine. To deep each integer from. So this is, oh, this is implemented recursively. So they do have recursion here. Do I want to implement my for loops with recursion? I don't think I do, to be honest. That's actually, huh. do I want to implement my for loops with recursion? I don't think so. I don't think so, to be honest. I don't think so. So I'm also going to stray away from fourth because I don't like how they did it. I think I'm just going to implement assembly for that, to be honest. So yeah, I'm gonna do assembly. I'm gonna do assembly. I didn't want to do assembly, or can I implement this in C instead? Let me think about it. Well, I need to access the top of the stack and two elements before that. So I will need a lot of registers, or have some like variable in memory to store that shit. Let me think. So I'll need one register for the quotes, one register for the low, and one register for the high. Yeah, I can do the following. I can do the following. So, oh, but yeah, but if I have like nested loops, okay, that's actually interesting. If I have nested loops, so I need to push stuff. I think I need to push stuff. Yeah. So, I need to say, so my stack, when I get into here, my stack is going to have like some stuff. Is going to have the low, the I, the quotes, and then it's going to have the for. So T is going to contain the quotes. That's the first thing, right? Then S is going to contain I, and sub Q8S is going to contain the low. And I can use well, yeah, I can do that. So I can do push quotes. What is like the let me see, where was it? It's not this. I can start closing this shit. Okay, I don't need that. Don't need that. Don't need that. I don't need that. I also don't need that. Okay. So is that push Q, I assume? So that, oh, push Q. There is no push Q, fuck. Push, word, double word, or chord, okay. Yeah, I think I'm just going to do push, and this accepts a register, yeah. Okay, so if I do push, do I need any specific thing? I don't think so. I just do push. I can push R13, all right? Yeah, so push T, and this is my return stack. So my return stack now contains the quotes, right? Then I can push the value pointed by R12, like so. Yeah, so I'm basically just pushing this. And my return stack is now going to contain that and the I, right? Then I need, so I need to also push that other stuff. So I can also do this. I don't know what is the actual like stuff to this. Oh, this can be removed, and that can also be removed. I don't know if this is actually a correct thing. In GCC as C inline Right. 64 bit actually. Bit x86 64 is this correct syntax? And then I subtract 16. This means that I'm subtracting this, okay, because I removed these two, right? Exactly. And then I need to keep calling that for as, oh, this one is that minus 1, basically. And I need to keep calling this one for as long as this one is lower than this one, right? Yeah. And I need to push that onto the stack, because if I use registers and my words contain, like if my code contains words that touch those registers, then I'm fucked, right? So I need to like persist that state somewhere. So I'm gonna persist it in the return stack. I think that's the most reasonable approach, to be honest. Yeah, let me just check. So okay, so it's like this shit. Okay, fine. Then it said here, why? So this output input. Oh, but I don't care about that. Yeah, I still need to do cobbler stuff. R12, R13. It probably touches that. It probably touches that. Okay. So now, I need to call. So the RSP. RSP is the one that contains the stack pointer, right? RSP. x86 64, right? RBP, oh, yeah, because which one do I want? Oh, but the RBP is the base pointer, right? I want the stack pointer, I think. RSP, fucking, yeah, I think I want RSP. So I basically want to call whatever value is in RSP minus, oh, but wait, the stack grows downwards, so plus, actually, plus 8, 16, 24, I think, plus 24. So this is basically going to be quotes, something like this, right? I think so. Oh, and by the way, this is actually 4. But before doing that, I need to say something like this. So for loop, right? Like so. But here, so okay, yeah. But here is, in this case, I want to do the following. So what is the instruction for less than? So I have this, yeah, less, or jump, jump. Which jumps do you have? Jump if condition is met. Okay, jump short if above or equal. Do I want my range to be inclusive or exclusive? It can be exclusive, right? Most ranges, they discard the last value, so they just go from, like, if your range is 0 10, your actual iterator is going to go from 0 to 9, right? So I probably want this jump short if above or equal. Yeah. And so I just use jrel8. Okay. So j. Oh, but how do you? Oh, okay. Carry flag. Okay, j. And here I need to do for loop begin, and this one can be like for loop end or something. Well, I can even, yeah, I can just jump to the end actually. Yeah, seems fair. And so I can keep this as for loop. And here I always jump there, right? I always jump unconditionally. So I want the other loop. I want this loop. I want JMP uh, that. So I always jump there and I test the condition again. Yeah, but I still need to add stuff. Yeah, so I basically here I need to do the following. I need to do add queue. It needs to be 64-bit because our ranges can be quite large. I don't know what the user is going to do, so we can do add queue. Let's see, add. Where is the add? Okay, I don't see the add queue. Fuck, where is add queue? Add queue. Not that one. Okay, so add. Add double precision floating point. No, I want the quad word one. I'm gonna assume that. Okay, fine. So add queue, the source is going to be, it's actually going to be yeah, it's just yeah, it's just one. So I'm just actually incrementing. Is that an inc instruction? Increment. Yeah, I think there is. In x86 there is one thing for everything. So I can just use inc actually, right? I think so. So this accepts memory. Yeah, it accepts memory, so it's fine. I can do inc and I can increment. I can increment RSP, right? Oh, but this one, like this one is still not going to work if I have nested loops, I think. Because I'm pushing that stuff. Yeah, I'm pushing onto the return stack, but I'm never popping. Huh. Yeah. Well, let's just try to figure out like a flat loop first. So I can do inc, and I need to increment whatever is in RSP. Oh, and here I need to also add RSP to my stuff. And here is going to be plus, well, I'm going to assume RSP is going to point at LO, I think. Yeah, so I do that, and I'm still missing the condition. Yep, okay. I'm still missing the condition, so less or equal. Or compare, is it compare? I think it's compare. Yeah, compare two operands, exactly. So this is how x66, 64 handles it. Does it accept to mem immediate? I'm gonna assume yes. I'm gonna assume that. And so I'm going to compare RSP and RSP. Wait. Why did I do 20? This should be 16. Assuming RSP points. Yeah, let's do this. And here I'm going to compare. So how is the actual stuff that you do here? Okay, whatever. So that's, and I'm going to compare that to what? To that plus 8, right? Because this stack grows downwards. So if I increment, I'm going to the lower side. So basically here, what I'm doing is low is less or equal than I, right? if ends. Okay, if that's true, ends. If not, call quotes, then increment low, and here go to for loop. Right. And here is actually if go to for ends. Something like this. Something like this. I think this is more or less correct. And this is at the end of the for loop. This is going to consume all of the values, all of these three values from the data stack. Is going to have some shit onto the return stack. Is this going to clean that up? I don't know. Let's try to put this in the clanker and see if it's actually correct. Check if this code is correct. If not, fix and explain why. I think it's something like this, to be honest. It must not be that far away from the actual stuff. Okay, the compare instruction is correct. The syntax is not valid. The correct syntax. Okay. Oh, okay. The plus symbol is not okay. So we can do that, and we can do that. It's fine. So the plus is not needed. Then with the value at address 8 bytes above the top of the stack. So the comparison should be okay. So I swapped these two around. Okay, that's fine. What else? The construct is also incorrect. The syntax. Okay, that one I already fixed. Oh, but the correct syntax is, and it requires to indicate that the operand is a memory address. Okay, so I need that to say, okay, this is a memory address. So it was not that incorrect after all. I kind of got it more or less well. Jump. Oh, they here they use it jump less or equal. Okay. Jump for ends. Here the guy is separated. Oh, okay, I see. Here he. Oh, this is not that good, is it? Because if it's less or equal, it goes there. But I can literally just say, okay, jump to the ends. So let's try that. So if it is that, if it is greater, so equal goes to there. So I just need to do if it is greater, right? Let's see. What is the jump? Yeah, the jump stuff for the other one, sorry. Jump condition. JA, jump short if above. So the guy used this one, the clanker. So I need to do the reverse. So jump greater, I think so. JG, something like this. JG, I guess. Then this one is fine. This one is fine, I suppose. Oh yeah, and here at the end it cleaned the stack. We should also clean the stack. Yeah. Yeah. But let me ask something. If I have two nested loops, is this going to work? Well, since I have two nested loops and I'm cleaning the stack, it may actually work. Wait, so yeah, I need to do a bunch of preamble and fuck. Let's not support nested loops for now. because I remember I still need to do something. So before calling the quotes, I need to do the following. I need to push the current iterator onto the stack. Yeah. So I need to say, okay, I need to say that stuff with a different register. I need to move whatever value is in RSP, right? So RSP into R13. But before doing that, I need to move the value of R13 into the stack. So this is basically the literal, right? Yeah, I basically need to do that. Right, like so. This is the body. Yeah. So I need to do this, and this is basically push it, but it's not really push. So let's call it lit. Yeah. And this is the same. This is all the same. Okay. This is all lit. Okay. And now the quote will start with a literal on the stack. Yeah. Okay. Is deprecated. Okay. So let's not do that. Where, okay, it doesn't even okay. Missing after percent letter. Let's see if the clanker can fix it. Within line semicolon is specifying the use of register names. What the fuck are you talking about? Okay. So here, but why? Oh, I see. Well, but this one is correct. Then circle. It's fine. Then 2. I can use 2. Why is it? I don't know exactly what line of code is fucking things. What the fuck? Okay. Let's comment these sheets. Like every single time I touch assembly, it's all fucked. I don't understand, truly. Okay, that one is fine. So if I add this instruction, it's also fine. If I add these two instructions, okay, one of them is fucked. I suppose it's this one. So I need 2 of them. Junk. Okay, that's because it doesn't have the instructions, but it's fine. Missing somewhere is probably here missing, I presume. Okay, so I can do that, and this one is also fucked, I presume. Okay, is this correct? No, there is an invalid. Okay, it's probably this one. Is this correct now? Okay, now we have a bunch of junk code apparently. We need to fix the junk codes. Okay. Jump greater after expression. Okay. Then to memory reference for compare. Okay. Register value. Okay, let's see what the clanker says. I'm already going to copy paste this because I already know that this probably this conversation is to fuck up the stuff. So I was I was not expecting the for loops to be so complicated. I'm gonna be honest. Oh yeah, fuck. I forgot. Okay, I forgot the new one. So the assembler is saying that this code is junk because it does not have new lines. Wow, brilliant. Okay. So is this no longer junk? Okay, it's slightly better. And the CMP, what did the guy do for CMP? Oh, this should be inc q. Okay, I can handle that. Then CMP should be where is even the okay? There too many instead of just RSP. What? But this holds a pointer, man. Okay, let's try to operand size mismatch. Oh, this is now operand size mismatch. Is there a CMPQ? It's probably something like that. Oh yeah, CMPQ. I already got it. All right. If I do that, no, it still complains. But why does it complain? I'm not even having. Where the fuck do I have CMP? CMP, CMPQ? What the fuck? Okay. So that is mostly fixed. One last instruction to fix. CMPQ, which compares the 64-bit value with 64-bit. Okay. However, the error message that there is a mismatch in operand size be due to the fact that you're using RSP as an operand, which is 64-bit register. But I'm using CMPQ. What the fuck are you talking about? I'm literally using it. What the fuck? If I comment this out, it's fine. Okay, let's try another shot. I don't know. Let's use that one. It may be slightly smarter, I don't know. Requires the destination left operand. Oh, this is the what? It needs to be an immediate. Ah. Loads one memory operand into a register, then CMPQ register other memory. Fuck. Or reverse order and use a register for the other operand. Ah, I see. I see. So I need to use the temporary register here basically. Fuck. Okay. So I can move one of them. Let's say which one did it suggest? This one. Okay, it can be that one. I can move this one into the temporary. So I can say temp is equal to this one is the I, right? I can do that. Then I can say that's low, I can say, yeah, I can say temp is equal to low less or equal, yeah. So I can do that, right? And now, oh, but why is it using a memory address? Okay, CMPQ x8664. It makes no sense, man. Yeah, well, let's it in reverse. I set according to the result, rux minus or rux plus. One of the flags set is carry flag, which is set to unsigned. It's actually, okay, so it should be fine. Let's try it. At least it compiled, I guess. So let's do the following. Let's add all of this scheisse into here. So for begin, for end. I'm not really confident that this is actually going to work. So let's see. And this can be here. And then we can do the same. Yeah, this is actually 4. And this is actually a 4. Okay. So if I do, I don't know, low 1, I, bam, 69, bam, and then 4, it didn't crash. It didn't crash. If I terminate this, oh, it worked more or less. It worked more or less. Oh, I see. But it is fine. It's actually fine. So it pushed that. Yeah, I see. I can see it. I can see more or less. So one thing that we need to do is that we need to consume these values. We forgot to consume those values. Yeah. So we need to consume all of this shit. So I pushed it. But I forgot. Yeah. So top is a ratio. It doesn't need stuff. So this one, that's 8, 16. Plus another one. It needs to be another one. So this needs to be 24 even. So it minus 3, because here there is one instruction missing. We need to do the following. We need to move Q. Yeah, something like this. Move Q from that minus 16 into R13. Because this is basically saying top is equal to stack to S minus 2. Yeah. Is equal to that. Right. Like so. It does not change the stack. Yeah. But here, our stack gets just that. Right. So for it to visualize it even better, here what I'm saying, let me copy that. So here my stack is going to always have this sheet, right? It's always going to have this sheet. Then I do that, yeah, my return stack is growing. Then I do this, which means let's say, yeah, I can say this just to indicate it. I do that, and then I clean all of these sheets. I can say like 1. It's just to indicate that this is the first element of that. And then I clean all of these sheets, and it gets like this, right? Yeah. I think that was missing. I don't know if I have other bugs, but at least that is handled. So if I do this now, and if I do 4, I'm gonna get 0, 69, 169. I mean, it pushed something, right? It pushed something. So what's fucked now? So at least the stack is cleaned up, right? I assume. So if I do 0, 0, that, and then a 4, okay. So jump greater or equal. This one is actually like that, I assume. 0, 0, 69, that 4. Okay, so 0 iterations is working. 0 iterations is working. If I do 1 iteration, yeah, I have a trailing. I have, oh yeah, because yeah, total sense, total sense. This trailing 0 is the one that I'm pushing. Is so yeah, it makes total sense. Is the iterator because my quote is it has this thing, so it gets that. So I'm gonna say this S. I'm gonna denote it at like this. So this is a stack, right? Then it's also going to have the I, and it's going to do whatever it wants, right? So this 0 is actually this iterator. So my for loop is actually correct. So if I instead define, let's say 0 to 10, I drop the iterator because I don't care about it. I drop it, and I just push 69 onto the stack. And if I do 4, I should have 10 69s at the end. Let's try it. Yeah, like we can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's correct. It is in fact correct. That's great. Let me see if this works recursively without any changes. I don't think it's going to work like with nested for loops, but if I say, let's say 0, 2 for the outer loop, I do drop 69, and then, well, I can do, yeah, I do drop, and then I do 0, 5, I open another quote. Yeah, this is not going to work because I don't allow this, but I could allow it. I could actually allow it. Let me terminate this. Is there any reason for me to not allow it? I don't think so. Like this one, I don't know why I stopped allowing this. Because this does not make sense. But this one, it does make sense. We may have, yeah, we may have stuff. We can allow it for now, just to check. Yeah, why not? Just do that. So 0 to open, I drop the I, the element of the loop, then I do 0, 5, I do another quote, I drop the J, so this is like the J, I push 69, I do that, and I do 4, oh fuck, I need to do 4, and then that, and then another 4. Yeah, you get the segmentation fault, so that's not really working. But at least like flat loops are in fact working, right? And then, yeah, well, it's like I can even do something like this, right? So if I want to generate all numbers between 0 and 100, I can do that, and bam, I have all numbers between 0 and 100, right? So this is basically our range. We can define our, oh, well, that's actually very interesting. That's actually very interesting. We can literally say that the word range can be defined as whatever is on the stack, empty quotes for terminate. Fuck, what happens? Oh yeah, because I cannot use quotes inside. Yeah, I forgot about that. Well, let's see if this is a quick fix. Well, I could have, like, let's say, I could have words modes or words compilation mode, and I could have like another flag, and I can clean this up in a future video, like a quote compilation mode, I guess. Right? I mean, it's one way of doing that. Here I just need, yeah, an or. Exactly. So here, this is that. Yeah, that's that. That's that. Here we can just disallow it for now in case of a quote, right? Because we don't support nested for loops, we need to change the assembly code for that to be working. But we can allow it to be compiled inside the word, I think. Oh yeah, fuck. Fuck, I now understand. I now understand why it was fucked. Because here we need to check two different cases. So it's the same thing as a literal. If we are compiling a word, so words compilation mode, else we are like in the REPL, so we can do that. So it's literally the same stuff. Interesting. That's very interesting, actually. So here we need to copy the literal. Yeah, we need to copy that and that stuff. And we can remove this like so. And this is the address, actually. It's interesting. So now I think this is actually going to work now. Because, well, but we can be... No, it's fine, it's fine. I think it's fine. Because that's going to be pushed. Oh, wait. So if my bump allocator, so if I do something like that and I have like 0, 0, 1, that's something like this, 4, 4, and here I have 0, 1. So my bump allocator is going to push that onto the data stack. It's not going to influence, right? It's not going to be influenced by, it's not going to influence the bump allocator, but this sheet is going to, since it is in the REPL mode, is going to push something like a literal. It doesn't matter. Then this is going to push 0 and push that. But here, this one also needs to be done like that way. Yeah, I think so. Yeah, so I think that's why it was not working before, because here it either word compilation modes or code compilation modes, it still needs to produce code. It cannot be like immediate. So we can only do that immediately. Yeah, on the stuff. But then word compilation mode needs to be an integer. So it's the same stuff we had before, right? Yeah. So if that's an integer, here we need to increment it. Here we can try to support it. I'm not really sure if my reasoning is correct, but we can try to support it. So word compilation modes, it can be that, but at the end, like so. And then I think I'm gonna do the same mistake I did last video, but let's go roll with it. Code compilation mode is going to be that and that, like this. And in this case, it's always going to push the return. Is it? Yeah, it can. It can do that. I think so. All right. I'm not really sure if this is going to work, but let's try it. If I do range, then that's okay. At least it does compile at least. And now if I want all numbers between 0 and 25 range, it compiled. Did it work? Oh, interesting. So 4 was never called. Was it? What happened to 4? Did I add 4 here? I must, yeah. So it wasn't really interesting. So if I do, just to make sure, 0.25, that 4, this one works. But yeah, I need to check like the compilation. I don't know if yeah, it's already almost 2 hours. So if I define R 0.25, then 4 bits, and then I do, oh, that, well, if I call R, yeah, it looks like the 4 stuff is not being, for some reason. Why is that? Interesting. So 1, 2, 3, 4, 5, 6, 7. I wanted to see where the fuck is my 1, 2, 3, 4, 5, 6, 7, 8. So this is my 0. Then this is my 25, I guess, or something. This is probably 25 because it's 19x, right? Then this is probably the quote. We should have a C3. Yeah, this is a quote, which is an empty one. Yeah. Then this is my 4, this big massive stuff. I don't understand exactly why this is not working, to be honest. Huh. So let's try to ask one last time to the clanker, and if the clanker is not able to figure it out immediately, I think we can finish the episode for now, because like we already support flat for loops, right? We already support flat for loops, so it should be okay. We can figure it out in the next video. Why is my for loop inside defines inside the words not working? Yeah, I think, yeah, fuck. So that's the issue. Yeah, that's the issue, because yeah, that's the same issue I think that is related to nested for loops, because I need to preserve the return stack values manually. Yeah, for begin pushes 3 values onto the call stack, which writes to the caller stack at RSP. Yeah, expects the normal function prolog and epilog layout. Your for primitive never sets up a proper frame and lowers the caller's saved return address and locals. Okay. Don't use the caller stack RSP for VM temporaries. Allocate a proper frame on the current function stack and use fixed offsets from RSP after. So yeah, Yeah, I think yeah. So it's telling me to say, it's basically telling me to create a stack frame. Give me the correct code so that I copy. Yeah. I don't know if I like this approach of the for loop. I'm thinking about it. I think I'll need to think about it for some time. Well, we can try that. We can try it. So let's assume this is correct. So basically, this is going to create a stack frame just for the for loop. So for loop is going to behave as a function, and I don't know if I like that. I need to check if there is a better way to compile a for loop. In this, we like with the restrictions that we have for the for our stuff, right? So this is creates stack frame, then store low I and quotes in frame, right? And this does, oh, it uses, okay. Why did it use like that? Oh, because it did a sub here. Fuck, okay. What if I don't do that sub? Um, so it's going to subtract 30. Yeah, what if I don't do it? Is there any issue? Okay, I mean, if I do push that, it's going to push that. Yeah. So it's RVP minus 8, and then it does a bunch of stuff. I don't know why. Okay, sure. Oh, it's okay. I see. I see now. I see why it did it like that. Oh, but it's adding a lot of fluff. Like this, man. This is doing it like the GCC stuff. So it's adding a bunch of fluff that I don't want to. Let's try it like that. Yeah. It's missing stuff. Like we can try. We can try it like this, but I do not promise anything. Because this is probably still going to work it like that. No, it's not going to. Okay, so let's revert that, and let's keep it in the working way. And next video we can try to figure out one like a better way of compiling for loops. That firstly it supports nested loops. It supports being called within word definitions, and it can be like slightly faster, I guess, because I don't think we need. I mean, we inevitably need to store shit in memory, right? Because if we're going to have for loops, we cannot reuse the same registers all the time. So, I mean, yeah, there is nothing about it. So we will need to use memory either way. And I don't think there is much less to be optimized here in that case. We just need to have like proper management of that memory, and probably just use like the stack frame stuff. But I mean, for now, I'm pretty happy with the conclusion of this episode, because look at this speed. Like even calling an empty like quotes, and if we try to generate 1,000 numbers, fuck, this didn't work. Okay, did I fuck up something? 0.25 and then 4. Okay, so 1,000. No, it should be fine, but I don't know why. So there is like a cap right now. I need to figure out where exactly is the cap. Okay, 500 also does not work. There is something very strange. 100 does work. 250. It also does work. So there is like some limit somewhere that we are eating. Probably because the implementation is all fucked, right? So this implementation only works until, let me try to figure out. Yeah, 400 does not no longer works as well. So 350 maybe. Yeah, 350 works. So okay. Oh, so 350 it entered this very strange. Ah, okay. So between 300 and 350 there is something fucked. Because it entered like a loop. What's... Oh, wait a minute. Wait a minute. So if I do 255, this is probably fine, I presume. Yeah. But if I do 256, this is probably fucked. I'm already smelling it. This is probably some overflowing of some byte. No, this is... No, yeah, this is fucked. Okay, I can see it. So basically 255 is the maximum number that can be represented with a single byte, right? Because a byte can represent numbers from 0 to 255 unsigned. So somewhere around here there is a byte overflow somewhere. Maybe here, I don't know. I need to check it, but I think I'm using like, yeah, I'm using quad words everywhere except here. But I don't know. I need to clean that shit up. But yeah, up to a byte counter, this works, right? Up to a byte, this is fully working. So yeah, I guess that's everything for today. So thank you for watching, and I'll see you in the next one.